Hello, everybody. Happy Wednesday. Welcome to today's webinar on Playbook optimization. I know this topic was something that came out of popular demand, and uh, yeah, we just, myself and Mike, along with the other, CSEs and the CSAs on the team, we've been really focused on uh, uh, we've been really focused on documenting good optimization practices and basically educating our customers to make this a good practice in their use case journey. So we're going to be talking a little bit about playbook optimization, why it's useful, and the various strategies that we typically recommend when we're reviewing use cases in playbooks with customers. Just to start, my name is Rahul and I'm a SOAR engineer in the customer success team here at Palo Alto Networks. I help guide customers through their journey on XSOAR by providing expertise on use case development. Along with me is my co-host, Mike.
Good morning, everyone. I'm Mike Beauchamp. I'm a XSOAR architect here at Palo Alto Networks. Happy to be presenting with you today.
All right, thank you so much.
That's right. That's right.
That's right. Yeah. All right. Okay. So just a little bit of introduction here. Everyone knows how important automation is to their current processes right now. So basically, as we have industries scaling up on automation as a way to get more efficient at carrying out day-to-day tasks, the need for deliberately structured and well-designed playbooks becomes absolutely critical. This actually ensures that there's great returns for the efforts that are spent in building these use cases. Playbooks are basically the bread and butter of XSOAR, right? They're visually descriptive flowcharts of data that enable automating a wide spectrum of use cases. XSOAR playbooks are powerful, pliable tools that enable developers to design and iterate use cases rapidly by providing a plethora of built-in features and functionalities. These can be leveraged to automate the most trivial, repetitive tasks to convoluted processes that demand a good deal of developer attention. Developing playbooks is exciting work, as you all know, but often the not so glamorous aspect of optimization in the use case journey is ignored until much later. Developers who appreciate the potential of playbooks, but at the same time are also aware of how they interact with other pieces in the platform and the impact that it has on its health, can set themselves up for success if this awareness is cultivated right from the start. This webinar is catered towards playbook developers. However, anyone interested in the or anyone involved in the conception and design of use cases to be automated on XSOAR will equally find this beneficial. Last but not the least, if you have any questions, please throw them in the chat and we will be addressing them at the end of the presentation. All right. So for the agenda, well, we want to basically focus on the most common things. First of all, stress on why playbook optimization is important, why exactly we're doing this webinar in the first place, right? What warrants a topic like this? The second thing that we're going to be talking about is optimization strategies in relation to anti-patterns that we commonly see when we're reviewing playbooks. When we're doing health checks, when we're reviewing playbooks, or when we're building playbooks ourselves, right? Sometimes we get carried away by the end goal, and we don't often focus on making sure that the playbooks are efficient all the time. So we focus on optimization strategies and anti-patterns. The third agenda is system diagnostics as it relates to playbook optimization. And last but not the least, again, we have the Q&A section. All right, let's move on to the first topic on the agenda, why playbook optimization is important. Today, as you all know, we will, we'll be discussing playbook optimization. It's a topic that is perhaps one of the most critical yet overlooked pieces in the content development paradigm. So our goal here is to equip playbook developers on XSOAR with knowledge and tools to build elegant and efficient playbooks while discussing pitfalls that can be avoided with a small amount of awareness. Yeah, I'm going to throw a small analogy here. So just to keep this light a little bit. I'd like to think of the relationship between the platform XSOAR and the content in this way. The platform basically functions like an engine in a vehicle and content like the steering wheel that sort of guides the processes from start to completion. Hypothetically, if a vehicle may be fitted with an extremely efficient and reliable engine and assembled with best-in-class safety add-ons, but a slightly misaligned steering wheel could compromise the driving experience, as you all know, surely, while navigating tricky moments on the road. So similarly, the process of shaping and tuning automations and playbooks iteratively need to be baked into the development journey to maximize quality and efficiency, and in turn establish a foundation for good experience for the users. Personally, I've just been really extremely fortunate to have had the opportunity to participate in so many use case journeys with my customers, right from laying the seed for the initial idea to witnessing the process bear fruit. But I must confess, though, that in my experience working on use cases with my customers, I've often strayed off the path in pursuit of shiny objects, but I've almost always been reminded of the importance of grounding the work in a strong base of fundamentals. Some things I learned early on, some things I learned way into my journey, but I still learned. That's the important part. I sincerely hope that you find this presentation as a useful reference of information that you can integrate into your playbook development mindset. Right. Let's get started with playbook optimization strategies. Over to you, Mike.
All right. Yeah. So I'm going to show you guys a couple strategies for optimizing your playbooks. We'll start by going quickly through the slides, and then we'll show you what you really want to see, which is a demo. First one we're going to talk about is that bigger is not always better. We'll explain this when we get into the demo. I'm going to go to the next slide, Rahul. I'm going to talk about the use of auto extract within playbook tasks and why you should be mindful of where and when you use it. And then the last one for you, which is on the next slide, just want to make sure you see all the memes first, is the use of sleep tasks, which is actually something we look for within our playbooks and why we look for it and how it affects how your playbooks run. So with that, if you want to stop sharing, Rahul, I will share my screen.
Right, over to you.
Make sure I pick the right monitor. Rahul, can you see my screen? I'll take that as a yes.
Yep, I can see it, Mike. Yep, I can see it.
Perfectly. All right, so the first thing I want to talk about is that bigger isn't always better. So a lot of times we see customers who build one playbook to rule them all. Now, if we take a look at this playbook, and this is reconstructed based on things we've seen, and we start zooming out. At some point, even our dbot icon is looking at us strangely, giving us a head tilt and wondering what exactly we're doing. In this case, we have a monolith. We have one playbook that attempts to do everything. And I'll be honest, when I'm confronted with a playbook like this, my biggest concern isn't that it's very big. It may work flawlessly. My concern is that it's nearly impossible for anyone but the person that built this to maintain. Let's face it, if I win the lottery tonight and Rahul inherits this playbook, we're probably friends off. This playbook is so big, it's in danger of becoming self-aware. So let's talk about some strategies on how to fix this. So one, remember that bigger isn't always better. We'll take a look at a slightly different playbook that is tailored to the specific use case that it is designed to automate. In this case, this playbook is much smaller. And if we take a look, and uses sub-playbooks to encapsulate specific logic, right? So when you're building your playbooks, if you approach between 40 and 50 tasks, you need to start considering a few things. One, is everything you're doing required, or is it a nice to have? A lot of times when looking at those large playbooks, right, we look at past runs of the playbook, and we can see that in a lot of cases, the majority of the playbook is not utilized, right? So this makes me question, do you even need these parts to the playbook? Other techniques are looking at different parts of the playbook and realizing that they may encapsulate specific functionality that you can put into a sub-playbook. In this case, you may have sub-playbooks that are designed to perform specific actions, such as resetting a user's password or blocking domains or URLs. These sub-playbooks can be designed to take specific inputs and then perform the task for which they're designed. This means if you go back, you can simply embed these sub-playbooks into your parent, right? And they can be then used to perform those tasks across other playbooks. Okay, so if you're approaching a playbook or a use case, there's no hard or fast rule on how many tasks are actually required, right? But if you're getting to that 40, 50 range, that's where I start asking, is this actually required? Or can we take specific parts and put them into sub-playbooks? This makes them much easier to manage, right? Maintain and iteratively improve. If I need to change the logic, I can simply go to my reset user password sub-playbook and modify that. Okay, but do not try to build a monolith. They are extremely hard to maintain. And I'll be honest, when I'm approached with a monolith, they're very, very hard to optimize for that reason. They're simply too big. Okay. Now, when looking at previous playbook runs, one thing we do as part of our health checks or just looking for efficiencies of playbooks is check the data that the playbook is generating, both the inputs that you're passing into the playbook, as well as the outputs those tasks are creating, and even what's being placed into context. And we do this by looking at existing instances that are executing this playbook. Now, between what I'm about to show you and our system diagnostics, we get a lot of insight into how our playbooks are functioning and whether or not we can optimize specific things. So on my screen here is a phishing email that was sent in, and we have run our standard phishing playbook against it with a slight modification. In this case, we take a look at the work plan. We're basing this off our phishing generic v3 playbook, but we have chosen to add in a task that checks whether or not the sender, and hopefully the demo gods are with me, is on the safe senders list. So for this, we've used a sub playbook that basically checks whether or not the sender is on a safe senders list. By taking a look, we can see that this task was automatically tuned into quiet mode, which doesn't bode well. But we can take a look at this playbook by running a command within the war room. This can be done from your playground as well. This command is called get INV playbook metadata, and it basically takes the incident ID and returns how the playbook functioned to the war room. Now, as CSAs or CSEs, what we're looking for out of this is things that are outside the norm. So if we open this in a new table, so far the demo gods are maybe agreeing with me, maybe not.
Yeah,
okay,
so far so
try
good.
this again. Yeah, wants me to log in. Try it again. All right, we'll do it from here. So basically what this task is showing us is the tasks within our work plan that ran, and basically the task ID, the name of the task, and the size of the inputs or outputs that it generated. Give me 1 second and see if I can log in again. All right, so basically the output of this task shows us for this incident ID, the task names that ran, and the outputs that were generated. The minimum size or default for the tasks to report here is 10 kilobytes. So anything bigger than 10 kilobytes is going to show up. Now, when looking at this output, we can see that one of these things is not like the others. This particular task, which is setting the good email list to context, is much larger than the other ones. If we take a look at the work plan and drill into the sub playbook, basically in this case, we've seen users set an entire list to context. In this case, I can tell you the list is 20,000 items long because I created it earlier yesterday, which generates a very big input as well as a very big output. And XSOAR has automatically tuned this task to quiet mode because of that, right? As part of optimizing this playbook, doing this across every single phishing incident may not be the best way to do it. Okay, so we can take a look at what it said. Here's the massive list, and you can see that it's been truncated because it's much larger than 51 items. It's still in context, but it's not an efficient way to perform this task. If we go to a similar or the same email, so this is the exact same email, but using a different version of the playbook, and I'll show you them in a second. If we run this task and get INV playbook metadata, incident ID, and we're going to give it number 36. Okay. We can see that in this case, that particular task, hopefully this works this time, does not show up as a result. It's because we've changed how it's being run. And we were clued into this issue simply by running this command against an incident that has been running our playbook for some time. Just showing us that, hey, this one's a little bit bigger. Maybe we don't need this type of output, or maybe there's a different way to do it. And Rahul, I don't think the demo gods like me on this one. I think they're angry. So we'll switch to the work plan itself.
I'm concerned about my.
So in this case, instead of setting the list to context, we're simply using a conditional, right? That checks the list as part of it. It does not log the inputs or outputs, but still gives us the same result, whether or not the sender of that email was on the same, on that list, and then returning the result to the parent. Same result, much more efficient playbook, right? Clued in by just using the get INV playbook metadata to take a look at what's being passed in or out, and there it finally loaded. Okay. So when you're reading this, if you run this on your existing instance, again, you're getting the incident number, the specific task name. You can see the ID, which has the little number when you're looking at your playbook, what the item is, and whether it's an output or an input. So inputs are called argument. And then the actual size of those specific items, right? And just running this command against existing incidents clues us into these potential optimizations, where if one thing is much bigger than the others, is there an opportunity to improve? If we pivot to system diagnostics, and we'll cover this very quickly, about system diagnostics, we can see that the system diagnostics is actually warning us about this. We can see that we have tasks that are being tuned to quiet mode due to their size or the number of entries they're creating. And if we click view details, we can see what those specific tasks are. In this case, I ran that phishing playbook 3 times, and each time it's warning me that it's automatically tuning it to quiet mode. So be aware that you can take a look at the playbooks that you're running, right, and take a look at the opportunities to optimize or improve them using this technique. All right, moving on to the next one, which is auto extract. So with auto extract, if you're not familiar, the best place to perform auto extract is on incident creation. We can do auto extract on playbook tasks, but we need to be careful as sometimes there are unintended consequences of auto extracting from every task. For example, we have this specific incident that ran that previous playbook I showed you that responds to a specific suspicious URL. This is a custom playbook. Right? And if we look at the indicator section, everything looks pretty good, except for this guy, right? A lot of times we'll get a question, where did this indicator come from? Well, in this case, if we look at the work plan, and we'll pivot to the playbooks quickly. If we look up the lookup user and Active Directory task, this particular task was set to auto extract indicators in line, which means it's going to extract indicators based on the results of this task. Well, .bank is a valid TLD. So it extracted bobby.bank as a domain. That's where it came from. As we review playbooks, we will often look at the playbook. So we'll go to this same one. We'll click edit to get into it, make it a little easier to see. And we'll often look at the specific task and whether or not the indicator extraction mode is set to inline or out of band. Now, the default for playbook tasks is not to do indicator extraction, but oftentimes we find it's turned on for reasons unknown. If you don't need indicators from this task, we can turn it off. This means that bobby.bank doesn't show up as a domain. right? So we need to be careful about using indicator extraction where necessary within our playbooks. And it is something that we look for when we review them, right? Is indicator extraction turned on different tasks, and why? Sometimes it's turned on because it's required. Other times it's turned on because you didn't know. So be careful where you use it, but it is something that we are very specific at looking at to make sure that we don't generate false positives or extra domains like bobby.bank. All right. And the last thing I'm going to talk about before giving it over to Rahul is the use of the sleep task. Give me 1 second. I'm going to kick off a command. All right. So within playbooks, we often see the sleep task used to wait for something. It could wait for 30 seconds to wait for something to run. It could wait for 2 days to wait for the desktop team to fix a laptop or re-image it. Okay. When we're looking at playbooks from customers, we're looking for playbooks that utilize this sleep task for a very specific reason. And the nice thing is that they're actually quite easy to find. So from the playbook library, we can actually search for a script. If we can do .name, we can actually type sleep. And it'll show us the playbooks that utilize the sleep automation. In this case, a custom one that we created. When reviewing the sleep automation, we look for one thing within the playbook. Under the Advanced tab, we're looking to see whether or not the sleep automation is set to run without a worker. Why are we doing this? Because the workers control the number of things that XSOAR can run in terms of playbook tasks. If I get out of here, and pivot over to my system diagnostics, we can see that every single one of my workers is currently consumed. This means that nothing will run in my XSOAR instance until a worker is freed up. Everything is queuing up behind it. If we take a look at what is consuming my workers, and this can be done using an endpoint called /workers/status. Oh, apparently they're all done. So let me kick this off one more time. Okay, we can see that every single one of my workers is consumed using the sleep task. You can see it's task number 2, sleep while waiting for service now. In this case, all of my playbooks are waiting and every other playbook is queuing up behind them. Right? Reviewing the playbook, we can solve for this problem. 1, by searching for playbooks that utilize the sleep command. And 2, under the Advanced tab, setting the task to run without a worker. Now, here's my warning to everyone on this call. The sleep command is the only task that you want to do this with. If you set all of your tasks to run without a worker, you will have problems. But the sleep one is the exception. In this case, we do not want our tasks to hold a worker while sleeping. Alternatively, if you are going to sleep for a long time, there are other techniques you should investigate. Things like generic polling are useful to check status in a third-party system and wait for a result. In addition, you can use SLA timers and SLA breach scripts to do sleep for you, having the timer complete a task to move the playbook along. If you're interested in how to do that, we just posted a video series on our live community. I believe it's video 10, but don't quote me on it. That actually shows you that exact technique. Just be careful when using the sleep command is all we're saying. We see this quite often, and it's a very simple fix. And with that, I'm going to stop sharing and turn it over to you, Rahul.
That was awesome, Mike. Thank you. And yeah, I'm glad you mentioned the live community resource. Please do check it out. It was built by none other than our own Mike. So it's got a really useful set of resources pertaining to all things, playbook development and all of the advanced concepts that we often cover when we're training customers on XSOAR. So please do check it out. And yeah, I will get started with my part of the presentation here. So I'll be covering 3 topics. First, let me just move through each one of these topics just to give you an idea on what I'm actually going to be talking about. The first topic, or the first area, will be classification and mapping. The second area will be the context, which I'm sure, as all of you know, is really, really important. And the third one is going to be quiet mode. So moving back to classification and mapping. Before I dive into the demo, I just want to take a quick moment to briefly kind of explain to you, what these are and why these are important. So, as you all know, classification is a powerful tool that places incoming alerts in appropriate categories or incident types in the XSOAR lexicon based on a classification key. Oftentimes, users will need to integrate with shared resources like mailboxes, log aggregators, and tools that alert on a wide variety of detections, right? This can lead to discussions on how to cleanly ingest and categorize incoming data without having to incur a heavy cost in managing these services. Classification allows users to integrate with these services and streamline the flow of alerts into processes that act on them. The natural advantage that sort of arises from leveraging classification is that it prevents users from creating multiple instances of an integration or API connector on XSOAR to fetch disparate alerts. And instead, it relies on its dexterity to kind of designate them to the right incident types without a lot of heavy lifting. This means that you can have a single instance of an integration fetching various types of alerts and delegate the classifier to direct these alerts to their appropriate types. The second thing is mapping, which sort of always goes hand in hand with classification. Mapping is another powerful tool that is used in conjunction with classification. It's used to homogenize data from the alert in a way that is accessible and actionable. Mapping establishes consistency in the way that information is retrieved and stored in an incident. It also prompts the system to index data and renders capabilities for searching, reporting, and calculation of metrics. A good foundation for handling incoming alerts and normalizing data by way of classification and mapping, respectively, in preparation for the playbook ensures that users will not have to have custom strategies to accomplish these tasks. So yeah, I swear to God, I'll be diving into the demo, but just one common anti-pattern that we come across is the delegation of classification and mapping responsibilities to the playbook. In the playbook, these are usually manifested in the form of multiple conditional branches that determine the incident type based on some condition and dedicated tasks to map information from labels to fields, respectively. These tasks introduce an additional layer of complexity and can cause the playbook to become sort of unmanageable. It is advised strongly to make use of these tools as a way of best practice and to enforce division of responsibility. And now I will get right into my demo environment here. All right. So yeah, I'm going to start my demo by saying that I hope the demo guards are with me.
I'm with you.
Okay. Yeah.
But I'm not the demo god. So
yeah, earlier, when I was trying to run my when I was trying to test out my demo, for some reason I couldn't get 2 tabs to open up in the browser. So I had to kind of switch back and forth between the tabs. So what I'll do is I'll take you to the settings page, but I've configured 2 integration instances. So what these instances are basically doing is just creating sample incidents. One integration here, one instance here is creating an incident with data that resembles a malware type of alert. The second instance is creating a sample alert with data that resembles a phishing incident. As you can see, I have no classifier and mapper set up here for this instance. Likewise, for the other instance, the malware instance. So if we go back to the incidents page where the incidents were created from those instances and look at the playbook. So we go to the work plan. Come on. demo words are not different. Okay, finally. I'm just too scared to move from one tab to another because yeah, it was about to load. It's going to vanish again. All right. So let me take you back. So here we have this playbook, the malware investigation manual without classification and mapping. So this was actually a result of another playbook that executed prior to this. So let's go there and we can trace the events that transpired. When I created the incident from the instance that I just showed you, it basically kickstarted this playbook, which is sort of a generic playbook. What this does is check the event type that's in the labels under the context data. So as you can see here, the event type says malicious activity, right? So I have some conditional branches set up to determine which path the playbook needs to be taking based on this event type key here. So when this condition determined that the event type was malware or malicious activity, it took us down this path. And here we have a set incident command that changed the incident type to malware, and then moved on to this task, which called set playbook. So it's really important to kind of be aware of what's happening here, because when the incidents were initially created from those instances, the incident type was assigned as unclassified. And this is common. This is something that we see commonly across playbooks, where we have an all-encompassing like sort of playbook that determines which path or which route process needs to go to based on some like the event type field that we're seeing here in the labels. So once the playbook determined that the event type was malicious activity, it took us down this path. It changed the incident type to malware from unclassified, and then it started this playbook, which is basically this one. Come on. So here in this playbook, this was actually a result of the result of a previous playbook calling this playbook by way of set playbook, the command. So let's not worry about what was happening here at the bottom. But what I'm trying to focus on is the first few steps where we're calling these set incident commands. What the set incident commands basically do is pick some data from the context of the labels and they assign it to incident fields. So as you can see, I have a bunch of data here on the labels. What each set incident call here is doing in this playbook is that it's picking some value from the label and assigning it to a field. So if I look at input results here, it's assigning the sample laptop value from the label to the host name, and then we move on to the next task. It's assigning the user that's again recorded in the labels from the alert to the user's field, and so on. So this method of calling set incident basically mimics the action of mapping, and the act of calling set playbook in the parent is basically mimicking the action of classification, right? So this is a common anti-pattern that we're seeing among playbooks that we're reviewing, where classification and mapping responsibilities are sort of offloaded to the playbook. So the strategy here to kind of address, the strategy here to that kind of shifts the focus back to classification and mapping is to make sure that you have a classifier and mapper in place that you can apply to the integration instances that they can access. What that is going to end up doing for you is that you don't have to do a lot of these housekeeping, a lot of the housekeeping stuff that we're seeing here in these playbooks, where the categorization happens as a result of the playbook execution, and the fields are being assigned as part of the playbook execution, when you can do all of that from within the classifier and the mapper files. So to the next part, we're going to apply a classifier and a mapper. Same thing to this instance. And then I'm going to enable this so that it creates two incidents. So this time, instead of creating those, instead of calling those generic playbooks that are routing the incidents to the respective types, it's going to call the appropriate playbooks by way of classification and mapping. And if we just quickly take a look at the classifier here, you can see that I've used the event type as a classifier key, and I've classified the value that I've extracted from the event type key to the respective types. So if the classifier sees malicious activity as a value for the event type, it's going to classify it to malware. And if it sees potential phish as a value for the event type key, it's going to classify it to phishing. And then let's go back to incidents. So we have the latest incident that just came in. So if we open it up, you can see that the incident automatically got assigned to malware, to the incident type malware, and the playbook is already running and executed. You can also, the other observation that we're going to be making here is that you can also see that the fields are mapped. So let's take users as an example. So you can see that the user field is already mapped. As part of the mapper, you can also see host name, which is sample laptop, which you saw earlier in the labels, was already mapped here, because we're mapping all of these fields in the mapper. So yeah, the benefit of using the classification and mapping feature is so that you don't have to employ your own custom logic in your playbooks to create these different conditions that determine the incident type and also map the fields, which is basically a huge advantage. All right. I'll quickly go back to the integrations disable, and then I'll move on to the next topic, which is the context. As many of you are already aware, the context is basically home to data generated by the playbook during the course of its execution, right? Before we dive into the discussion of context data usage, there's just one thing that I quickly wanted to clear the air on, which is a common misconception that users initially have when viewing the context. When you observe the context here in the context data viewer, actually, yeah. So yeah, when you observe the context here in the context viewer, you can see the incident object also. The incident object also appears to be part of the same scope as the context. However, it is separate from what we identify as the context because they have differing attributes. So if I simply run a set command here, so it creates a context entry for the key test, and the value is also assigned to the key. But at the same time, you also see the incident object. However, these two are separate entities. So we treat these two as different because of differing attributes. And also if we have different methods for storing, retrieving, and manipulating items in these two objects. The context is the main source of input to tasks in a playbook. It is also where the tasks store their outputs. The playbook is always like perpetually locked into the context for reading and writing data, as are automations and commands executed manually. So this characteristic of playbooks being heavily dependent on the context can often lead to misuse by storing large amounts of information and redundant pieces of data. Few things to keep in mind when working with the context. I'll be talking about those while I walk through the demo here in just a sec. So first thing you want to do is go object setup, incident types, phishing, and I'm going to change my playbook from phishing manual to phishing investigation. And let's go back to incidents. So I'm creating an incident of type phishing. And I hope to make this quick because we want to get to the Q&A section also. So we look at the work plan. Yeah, while it's loading, the first thing that I want to quickly highlight here is the scope. It's the scope of the context, right? Every sub playbook has its own scope, which you can configure in the playbook editor. You can either set it to private or you can set it to global. There's a toggle switch that you can control to set them to private or global. So best practice is to always keep it, is to have sub playbooks use private context so that so that there's no interference of data that's being generated by the sub playbooks with context that's available in the outer, like immediately outer scope, which is the parent context. And if I pull up the context real quick, you can see that you have specific sub playbook. You can see that you have specific IDs for each sub playbook that basically denote that the context is private for the sub playbook, and all of the data will fall underneath it.
And Rahul, what's the proper way to get data out of a sub playbook and back to the parent?
Yes, that's a good question, Mike. So best practice is, first of all, like I said, you need to make sure that the scope of the context is private to the sub playbook, just so there's no data interference. Just having private context basically make sure that you're able to decipher the outputs from various tasks within a sub playbook easily when you look at the context field, right? So when you want to feed a result from a sub playbook to the parent, or basically to outside the sub playbook, you want to make sure that you're using outputs. So when you're building a sub playbook, you can declare inputs and outputs at the playbook, at the section header, which is basically the top of the playbook, the first, like bulb at the top of the playbook. There you get to declare the keys, or the keys to output from the sub playbook to the parent. So this will essentially ensure that you're not cluttering the context by making it global just because you want to have some piece of data available with global context, or outside the scope of the sub playbook. It makes sure having a private scope will ensure that you're essentially sticking to best practices and you're outputting the results using the output declaration in the playbook. And I believe this is already executed. It's just taking a little while to refresh. All right. So as you can see here, like I said, each sub playbook has its own ID, and all of the results underneath the sub playbook will basically be specific to that sub playbook. But what happens if I switch up one of the tasks to share their context globally. I'll use one of my enrichment software playbooks, or yeah, I think that would be good. And click it back there. We'll delete the context so we have a clean slate. And also repopulate files so that we get back the ML file in the context. And then on set playbook, start the playbook. So this time, all of my enrichment modules are set to use global scope for the context. So you can see the impact that it has. You can no longer see the respective sub-playbook IDs. You will see that all of the data is being shared with the global context, if you will. All right, we already have a couple of enrichment playbooks that are completed. So you can see if you observed previously, we had sub-playbook IDs for each of these. We had IDs for each of these sub-playbooks in the context that were available. But now, since we switched it up to global scope for each of these sub-playbooks, you can no longer see the IDs under the context. So everything, all of the results that were generated from these sub-playbooks are now being shared globally with the outer global scope. So yeah, you can see URL, which is basically the results of the URL enrichment task that's currently executing, and the domain hash and IP lookup results are also available under the respective sections. So it's the domain being shared globally. So you don't have anything specific to the sublabel. So yeah, what I'm basically trying to say is that it becomes really hard to decipher, where the output is coming from, especially when you're troubleshooting something, and you don't know where the output is coming from. It can make your troubleshooting process really, really hard, make your life really, really hard if you're using global scope for the context. So yeah, so recommendation is to use private scope and use inputs and outputs to share data between layers in the playbook. Another thing with regards to the context is if you happen to see the context growing out of control, consider automating the deletion of objects within sub-playbooks that do not necessarily drive any outcome, right? You can use delete context and specify a key and optionally use the sub-playbook flag. To delete a specific key within a sub-playbook. So there's oftentimes there's data or there's results within a sub-playbook, or even in the parent playbook, that are not necessarily actually important to the investigation or to the overall scope of the investigation. So if you quickly see the context data growing out of control with respect to the size, and the system diagnostics page is flagging the incident as having a really, really heavy context, you can implement these delete context steps within sub-playbooks to sort of eradicate, or remove keys that you're not concerned about or do not necessarily drive any outcome. All right, so that's about the context. Let me just quickly spend a few seconds talking about quiet mode. I know Mike already mentioned quiet mode, but I just want to take a few seconds talking about it, and then we can get to the Q&A. Let me stop sharing my screen. I'll move to the slide deck actually. So last but not the least, I have quiet mode. Here is another analogy. Bear with me here. I've just been practicing meditation a lot lately. I just wanted to kind of plug it here. Uh, so yeah, just as sort of meditation teaches one to observe thoughts as they go by and not get caught up in the thinking process. Quiet mode instructs the task or playbook to remain impervious to the operation that's being performed under behind the scenes by ignoring the output of the operation in part. Quiet mode is recommended for scenarios that involve a lot of information that might adversely affect playbook execution. For example, processing indicators from threat intel feeds or running search queries against a SIM that pull back extensive amounts of data. When quiet mode is selected, playbook tasks do not display inputs and outputs and also do not extract indicators or automatically extract indicators. Tasks are not indexed, so you cannot search on the results of specific tasks. However, all of the information is still available in the context data, and errors and warnings are also written to the war room. Just as Mike demonstrated earlier, you can run the get inv playbook metadata command to analyze the size of the playbook tasks to determine whether to implement quiet mode for playbooks or tasks specifically. So you can get good insights from that command to see if there's any tasks, specific tasks in the playbook that have a particularly large, input or output, or if they're streaming a lot of results into the war room, which can be suppressed to speed up the playbook or basically to optimize data storage. You can toggle the quiet mode setting on for those tasks.
All right.
And
system diagnostics rule.
Yeah.
All right. If you want to stop sharing, I'll jump to system diagnostics. For more info on quiet mode, again, the videos we posted, there's an entire video on how to use quiet mode. All right. So the last thing we want to briefly touch base on is the use of system diagnostics as it relates to playbook optimization. We showed you different techniques, things that we're looking for as part of looking at playbooks and optimizing them. And the system diagnostics page gives you additional information. So a couple things we want to call out. If it's green, it's good. If it's yellow, I don't have any on my screen, it's a warning. And red is something you should probably pay attention to. For anything on the system diagnostics, you can select view details, and it will give you more information about the specific instance or tasks that are flagging this particular concern. In this case, the tasks being tuned automatically to quiet mode, you can see the ones where I was setting the big list. This is over 1.2 megabytes of data. So it's turning off inputs, outputs, arguments. Things are still going to context, but it's stopping logging those things because it's a very large task. I showed you a way to fix it, but when we're looking at this, if we're looking at individual items, right, if they keep showing up, it's an opportunity to improve this playbook, this task. For anything within system diagnostics, you can select how to fix. This will drive you out to the knowledge base, explaining what this warning is and how to fix it. In this case, any task larger than 250 kilobytes may be automatically tuned to quiet mode because of its size. Okay, so be aware, we're not going to tell you how to fix all of these, unfortunately, in this webinar, but you can select how to fix. It's going to give you more details. Now, as a tip, when we do health checks, one thing we look for is how close is it to the threshold. In this case, if all of your tasks were 255 kilobytes, maybe that's not necessarily a problem, that's just normal use. There are ways to tune system diagnostics. I would refer to the XSOAR and Min guide on how to do that. One last thing to call out around system diagnostics as it relates to playbooks is there are dashboards that are part of the common dashboards pack that show you your playbook runs, how many, which tasks have executed, and even the average runtime of specific tasks. In this case, you're going to want to review this and maybe look for anything that's an outlier or that's something you would not expect. You can look at it from a playbook standpoint, troubleshooting playbooks for playbook errors, etc., or even around your integration instances, which ones are running, which commands are executing, how long, and so on. And with that, we have a minute or two for Q&A, so I'll stop sharing and we'll tackle some questions.
Okay, there's some questions that are also coming in the chat. So let's see.
Oh,
Can you talk? First question from is, can you talk about sub playbooks and limitations? Too many sub playbooks. That's a good question. I, there's no such thing as a hard limitation to the number of sub playbooks that you have. Obviously, as we've discussed here in the webinar, having sub playbooks is definitely best practice, right? It keeps the playbook clean and modular, and also for anyone that's viewing the playbook, it just makes it a little bit more easier for them to make sense of what's going on in terms of the functionality. And encapsulation is always better than no encapsulation, right? So we don't have any hard limitations as such to the number of sub playbooks, except just going back to Mike's first topic on having really big playbooks. You want to be mindful of the size of the playbook and make sure that you do not overcrowd the playbook to basically so basically you don't want to overcrowd the playbook too much.
I would follow up just by saying, right, if it's repeat logic, put it in a sub playbook. It's easier to maintain. There are no limitations. We also had a question on nesting sub playbooks. That is possible, but the only caution I would say is if you're nesting like a Russian nesting doll and you're going 7 layers deep, you may want to rethink your strategy. Is that actually required, or is there a simpler way to do it? 1 level deep on a sub playbook, seen it done. We do it in some of our playbooks. 7 or 8 levels, probably not. Question on, is there a maximum sleep time that the system will allow for? Not really. I've seen things sleep for a week, but there are better ways to do that, right? I would definitely recommend using either generic polling to poll for the status of that machine in the external system, or using an SLA timer script that we talked about. And there's a great technique for that in that video series we posted. All right, let's take one more, Rahul. I'll let you pick it, and then we'll go on to the rest of the Q&A.
Cool. I have a question. Can you use mapping to map fields that are found in a CSV file when the incident is created? For example, a CSV file is sent as data with the fields user and IP. Can those be mapped at incident creation? No, you cannot extract data from a CSV file, basically attachments, because attachments are not available in the mapper. All that's available in the mapper is the raw data that's coming from an alert, whether it be an email alert or whether it be an alert that's coming from an integration specifically. Attachments are not actually available at the time the mapper executes. The attachment becomes available once the incident is created. So mapping can only be done on fields that are available as part of the raw alert that's coming from an integration source. So in a case where you have a CSV file and you have to map some fields, you have no other option than to parse the CSV file there and extract the values and then map them from the incident if you need to.
All right. And with that, unfortunately, we do have to drop. Thanks everyone for attending. Rahul, pleasure working with you as always, sir. And we hope everyone enjoys the rest of their day. Thanks all.
Yeah. Thank you, everyone.